Hello, everyone. Good morning, and welcome to the second day of droidCon APAC 2020. I'm Nick Dipatri, and I'm a principal engineer at the Comcast Corporation. I'm calling in today from Philadelphia, Pennsylvania, in the United States. Coroutines are a way to execute work asynchronously on a background thread. They've been around for over 50 years, but they're actually fairly new to Android, and that is why I'm here today to present coroutines with an air cannon. So today we'll be using coroutines to talk to this, my air cannon. And what I want you to focus on is this. This is the microcontroller, and it's built by a company called Particle. And the cool thing here is it has an antenna, a cellular antenna. So this air cannon actually connects up to the network, and I can communicate with this air cannon from coroutines. That's what we're going to do today. So what I'm going to do is pressurize air, and it's going to shoot ping pong balls out of this end, okay? So let's load it up with some ping pong balls, shall we? One, let's do three here. What the heck, right? Okay, so let's dive right in. So this is going to be a live coding exercise. Okay, so I'm going to dive down here, and there we go. Okay, so what we're going to do first is we're going to, again, our goal here is to talk to this air cannon over the network. Okay, so now this is not an Android project. Okay, but I'm using IntelliJ, which is what Android Studio is based on. So this should all look fairly familiar to you folks. Okay, so now this function, we can imagine this function running on the main thread in an Android activity. Okay, and now this part right here, this is our coroutine. Okay, now what I want you to focus on right now is that this code block is what I call coroutine world, right? And inside of coroutine world, we have this thing called the magic coroutine scheduler. Okay, and I want to explain later what that means. But right now, I just want you to know that this is inside of coroutine world. This isn't, and this is not. Only this, okay? So let's just go right ahead and try to implement this method to launch the air cannon. Okay? Now, before we can launch the air cannon, we need a way to talk over the network to our air cannon, to this. Okay? So to do that, we're going to use retrofit. Retrofit is how you do network programming in Android, typically. Okay? So here we go. Now, using retrofit usually involves two steps. Okay, first, you create this. This is the interface that we're going to use. This is the object that we get back from retrofit, and that's how we communicate with our RESTful endpoint. Now, remember, I mentioned that this is a particle microcontroller, okay? And this is a thing that connects up to the network. It connects up to this thing called the particle cloud. Particle, remember, is a company that makes the microcontroller, which is plugged inside here. Okay, so this retrofit interface connects to the particle cloud. The second part of using retrofit is this interface declaration here. This is where we define what methods we're going to call upon this RESTful endpoint. In this case, we're going to call get devices, right? Because I have many goofy things that I connect up to the cloud, the particle cloud, and one of which is the air cannon. So we need to get back a list of all the devices that we're going to search through. Now, the one thing I want to point out that's interesting right here is this. So this is us telling retrofit that when you make this network call, I want you to use coroutines, right? Remember, coroutines are the way we do asynchronous programming in a background thread, right? So what we're saying is, hey, retrofit, when you build this interface, I want you to use coroutines. Okay, that's all you have to know right now is retrofit is using coroutines to make our network call. Okay, so let's go back up here then. And we're going to say particle interface, get devices. Okay, great. Well, it's not compiling. Why is it not compiling? Well, the reason it's not compiling is because, remember, we're using coroutines here, right? Get devices is implemented using coroutines, but we're not inside of coroutine world, or at least the compiler doesn't think we are, right? We know we're going to be inside of coroutine world because we're going to call it here, right? But the compiler just sees this function. Anybody can call this function. So we need to tell the compiler, only call this function if you're in coroutine world. And the way you do that is with the suspend keyword. Now the compiler knows this will only be called from inside a coroutine world. Great. So now this compiles. Next step. Now we have a list of devices back, as you can see here, right? List of simple devices. Now we're gonna find our device. We're gonna find our air cannon, right? So we're gonna create a filter here, right? And we're gonna say, hey, if the name is equal to air cannon boron, right? This is our predicate. So this is what only devices that could pass this predicate will be the air cannon itself. So once we have the air cannon, we're then going to try and launch it. But for now, we're just going to say launching air cannon dot name. All right, we're going to put little braces here. Okay, looking good so far. Now, I think we can all agree that if I print this out to the screen, we have successfully connected to the particle cloud. We've gotten back our particular air cannon. Okay, let's go ahead and run this. So I'm going to, when I run, it's going to appear on the right side over here. So let's go ahead and run this. I'm going to zoom in a little bit. It takes a little bit of time to first compile. Okay, here we go. Great. Look at that. Launching air cannon boron. Now, again, we can all agree that we have just used coroutines to talk to my air cannon. Now, this end command is in the wrong spot, right? That's kind of weird. It's up there. We'll get to that later. And, agree that this is not really that exciting right now. We'll get to launching the actual ping pong balls in a moment. But first, I want to focus on this function right here. I want you to notice what a thing of beauty this function is, if I might say so myself. And that is because all the complexity that you normally associate with asynchronous libraries is kind of stuck into this magical coroutine thread scheduler that I mentioned earlier. So in fact, to really understand what I'm talking about here, I'm going to do what I call a main thread walkthrough. Let's go for this one step at a time and see what's happening when I run this, okay? Okay, so let's go up here. Now, again, remember I'm on the main thread here, and we can just pretend we're like in an activity somewhere, right? We're on the main thread. So we're on the main thread and we print start command right here, okay? Then we go down to here and we're still in the main thread. Now this is what we call a coroutine builder, okay? It's launching into coroutine world. Now this is important. When you launch into coroutine world, you don't necessarily change threads. In fact, quite often you don't want to. So when it encounters this, it schedules it immediately on the main thread and we get to here. And then we drop down to here. We're still in the main thread, okay? And now we go into here, still in the main thread. Now remember, this is implemented by retrofit. Now somewhere deep down in this method call, retrofit has to make a network call, right? Now remember, we're on Android, and we don't do network calls on the main thread in Android, right? Because the OS is event-driven, it would really mess up the UI experience. So we need a different thread of execution. And for that, remember, we told it to use coroutines. So at some point deep inside of this implementation, retrofit's going to switch threads to a background thread. As soon as that happens, that's a trigger to coroutines, to the coroutines thread scheduler. And it says, oh, we need to suspend this function. Okay, now remember, the background network call is still happening. It's still working in the background, but this function call on the main thread, it's going to be suspended. Now, what does that mean to be suspended? Well, when a method is suspended, its calling function is also suspended. So let's pop up here and look at this. This function will also suspend, and it's going to suspend at this point, remember, because this function also suspended. So what it means is a coroutine scheduler, it looks at what line number we're on. We're on line number 210, and it knows we're on the main thread before we suspended. It remembers both of those things, and it takes this whole function and puts it on a call stack. It puts it on a stack. It remembers it. And then it suspends the calling function. So it just keeps bubbling up. And then we get up to here. Now, I like to think of this code block itself as a suspending function. That helps me to remember this. So this code block is also going to suspend at this point. Okay, so once you get to the top, once you bubble all the way to the top here, all these functions have been suspended. They're in this like stack. This now, And this function, this code block is also suspended. It releases the main thread, right? The main thread is now released while this work is happening in the background and while all these functions are suspended. The main thread's released, we pop down to here. And that's why end command happens so quickly here, because we jump out of this pretty quickly. As soon as we switch threads, make that network call, right in the beginning, we pop down to here. Now, this is another cool part. Once we get down to here, we actually exit this function. This function returns. So now you have this suspended, we have this suspended, and we have this suspended, all while this network call is underway. Now, at some point in the future, and remember, the main thread is released, right? The main thread on the UI of the Android application is running along. At some point in the future, that network call returns. It returns a list of devices. And now we resume. Okay, what does it mean to resume? The coroutine schedule now resumes this stack of methods that you have suspended. So let's see what happens here. So once your resumed function returns, in this case, it's returning a list of these devices it got from the cloud, it resumes a calling function. So go back up to here. Okay, now coroutines knows it has to resume this function. So how does it do that? Well, first it has to wait. It has to wait for the main thread to once again become available. So it could wait a while, hundreds of milliseconds, who knows? So once the main thread becomes available, it rehydrates this function. It resumes this function at this line of code, and then it proceeds. So this returns back a list of devices, and then we're back on the main thread right here. We do this, and then this is on the main thread, and then we print this on the main thread. And that's where you see that. Okay? And so now once this function returns, it resumes the calling function. So remember, it only resumes after the function's done. So now you bubble up to here. Now this, what I call this code blocker function, also resumes. So it resumes right here, but there's nothing to do here, right? It's all done. So once it exits this code block, nothing else happens, because remember, this outer function already returned a while ago. So this code block just kind of exits quietly, and we're done. The coroutine scheduler did its job. Now that's a lot of complexity. But the cool thing about that is the complexity is in the thread scheduler, right? It's not in the code. And that's what I want to talk about now. Look at this. This is a thing of beauty. I keep calling it that, but it's kind of vain of me. But this is really simple. What I mean by that, let me qualify what I mean by beauty. It's imperative. You do this, then you do this, then you do this, right? It's what we call direct continuation. You directly continue from this, and then to this. Right? Now, if this were a different kind of asynchronous implementation, say callbacks, you have what's called continuation passing. It looks much more ugly. You wind up with what we call callback hell, right? And then, or you could use RxJava, and that presents different challenges. Like this, for example, would not be a simple list of devices. If we were using RxJava, this would be an observable of a list of devices, right? And then these operators would have to be RxJava operators. And that really gets complex, right? You have this whole other domain-specific language, or DSL, that you have to know. But in coroutines, the beauty here is this is just a list of devices. And then this, instead of being an RxJava operator, is just a Kotlin stream operator, filter, and then for each. Okay, so that is the beauty of coroutines. Now let's do something, enough talk, let's have some fun here. Let's go ahead and launch the air cannon. This is where I get scared because this thing's kind of loud. All right, so what we're going to do here is we're going to put another function here, another suspending function, which will fire the air cannon. So let's go ahead and put that there. Okay, fire air cannon. We got to give it our air cannon and the ID. Okay, excellent. All done. Now we're going to run this. I'm going to stand back here. Okay, I'm going to run. Now I'm going to switch the camera over to here. Oh, I got to plug it in. Okay, we got to run that again because I forgot to plug it in. It's kind of loud. So it's building up pressure, okay? And actually what it has is it has a transducer. It actually measures the pressure in the chamber. And then once the pressure hits a certain target pressure, it turns off the pump. Okay, so we're going to aim this toward you folks over there somewhere, okay? Now let's go back here. Let's run it again. Let's run this again. Okay, here we go. Okay, that was loud. Just in case you didn't catch that, let's launch it again as I changed cameras one more time. There we go. Now, it's pumping up. Now, when it turns red, that's when it fires. Also, it makes a very loud noise, so it's hard to miss. One more time. Okay, there you go. I think that's enough. I want to unplug it. It's pretty loud. Okay, move us over here. All right, so we did that. We launched the air cannon. Everybody give yourselves a hand. We did it. Okay, so now what's next? What do we do next? We've used coroutines to launch air cannon. We've only been talking for 15 minutes here. What else can we do? Well, we're going to make this more interesting. I built something else. Let me show you what else I got here. Okay, this is, I'm not sure what I'd call it. It's like a red siren, an air raid siren. What we're going to do when you push this button is it turns on a siren and you turn it off. Now, this is also a particle device that talks to the cloud. We can talk to it over the network. Okay, what we're going to do is we're going to tell our friends to duck. When we launch the ping pong balls, we're going to first tell everybody to duck, right? Everybody can get down while the rain of ping pongs are falling upon everybody. Then when the air cannon's done, we're going to turn off the siren and tell everybody to get back up. You get that? Everybody get down, fire the ping pong balls. Okay, everybody can get back up. That's what we're going to do. We're going to make this more interesting. So right here, let's tell our friends to duck. Okay? All right, here we go. Now, the first problem here, well, let's see this. First thing we're going to do is we're going to tell our friends to get down. Then we're going to turn on the siren, this thing. Then we're going to wait a while, 5 seconds, and then we're going to turn the siren off and tell everybody to get back up. Okay? Now, the first problem here is that these are red because we didn't build these functions yet in our retrofit interface. So let's go ahead and do that now. There you go. Okay. Now, this is a lot of mumbo jumbo. I'm going to ignore most of this, but I want to point out this. This is our function that we're going to turn on the siren. Now, notice it's not a suspending function. And that's because I want to tell retrofit not to switch threads. Retrofit's going to make this network call on the current thread that you call this function. Okay, the reason I'm doing that is rather sneaky. I want us to build our own coroutine this time. Okay, that's what we're going to do next. We're not going to use retrofit to build our coroutine. We're going to use this function ourselves to build a coroutine that switches threads and goes to the background. Because remember, if you don't switch to a background thread, you don't need to use coroutines. Okay, so this is how you switch threads in coroutines with context. Okay, and this is the thread pool from which we want coroutines to draw. Now, if you're familiar with RxJava, this is similar to the schedulers. Right, so schedulers.io, same thing. Now, once we've switched threads, we're going to print, get down, and then we're going to make this call. Now, remember, this is on the same thread. So we're doing this. This is a network call we're doing, but since we're in the background, it's okay. And then we're going to wait 5 seconds, and then we're going to turn off the siren. Okay? So let's go ahead and run this. And remember, we're doing this up here. Okay? So let's go ahead and run this and see how it looks. Can we launch it here? And we're going to switch back to here. Okay, let's watch. Okay, there you go. Remember, this turns red when it fires. Okay, what was wrong with that? Well, what was wrong with that was that we told everybody to get down and we told them to get back up, and then we fired the air cannon. What the heck is that all about? Well, it turns out that's exactly what we told them to do, right? Because remember, coroutines makes our code imperative for direct continuation. We do this, then we do this. Okay? The problem here is that these things are being done sequentially, but we want them to happen at the same time. We want them to happen concurrently. Okay, so how do we do that? Well, I've been talking about coroutine world quite a bit, right? And it turns out when I say coroutine world, what I really mean is this thing, scope. Scope defines our coroutine world. It defines the magic thread scheduler that we're using. And since we're using the same thread scheduler here, it's doing this and then it's doing that. And actually, this is usually correct, right? 90% of the time, this operation usually depends on this operation. This concurrent thing we're trying to do here is kind of anomalistic, right? But it's important, and that's why we're going to talk about it. So how do we do this? Well, the easiest way to do it would be to create a different scope, use a different coroutine world, a different scheduler. So let's go ahead and do that right now. Let's try that. So we're not going to make this a suspending function. So it's going to go from here right to here. Right? And then what we're going to do here is we're going to use global scope. Okay, so now we're using a whole different thread scheduler to do this, a different scope. Now, before I go any further, I want to tell you that this is actually an anti-pattern. This is not really the way we want to do this, but this is a good segue into the right way. So let's just do this and see what happens. So again, this is not a suspending function anymore. So we're going to do this immediately. We're going to do this at the same time. And this is going to happen on a different thread, right? On the different dispatcher's IO thread. Let's run this and see how it looks. Okay, we're going to run, and we're going to switch back to here and watch it. I'll squeeze in between both of them. Okay, it fired at the same time as we warned everyone to get down. That's good. And then that should turn off. Excellent. Okay, let's go back to here. Yay, that worked, right? It fixed our problem. But the problem with this is it's not following what we call structured concurrency. And what is structured concurrency? I mean, global scope is kind of like unbridled in this case, right? It's just kind of running on its own over here, and it's not structured. I did get what kind of structured concurrency means. It means we want some structure to this thing, right? So what do we mean by that? Well, to explain what I mean by structured concurrency, let's consider this thing that we've been ignoring, this end command, right? It's happening way up here. It's not obviously not printing in the right spot. We want to get a handle, an understanding of when our background work is truly finished. This is often what we want to do when we're doing asynchronous work. We want to know when we're done in the background, right? So let's take this and bring it into coroutine world. Let's try that and see how that looks. Okay. Well, it's a little better, isn't it? End command now happened after launching air cannon. That's great. And that makes sense because it's inside a coroutine world. But lo and behold, it's not inside of this coroutine world, right? And that's why I completely ignored it. This thing just kept on going. And in fact, it happened after this. So that's not helpful. And this demonstrates partly what we mean by this. It's kind of global scope is unbridled. It's a whole different scope. We can't track it. And that's not good. So let's undo this. Let's put this thing back to where we had it. And let's come up with a different approach. Okay, excellent. We're back to where we were now. So if I just ran this, it would be sequential like before. We got to come up with a different approach. Well, it turns out coroutines gives you something else, and it's called async. Okay. I like to do it like that. Okay. One more time. There you go. Now, what async is a different coroutine builder. Okay. And what it does is it automatically switches threads. So if we look into this thing, if we click down into async, we'll see that it uses dispatcher's default by default. So it's using a different thread automatically. But the cool thing about this is it actually does create a whole different thread scheduler. But the cool thing is it's actually a child of this. There's an inheritance relationship now. It's structured, okay? This is where we get structured concurrency from. So although this is a different thread scheduler, so this you can think of this as an inner thread scheduler and an outer thread scheduler, a child and parent. And this ducking is what's called a deferred. Okay, I'll show it here. It's a deferred, right? And that deferred, you can think of that in other languages. It's often referred to as a promise or a future. And in Android, in RxJava, it could be a completable. This is a way for you to track this other work. So what we want to do, it's a way for us to connect these two different coroutine worlds. So let's do that here. Okay, await. Now, what this does is this outer coroutine runs, it gets to here and immediately jumps to the next line. This doesn't block, right? It launches a different coroutine, and this outer coroutine immediately jumps down to here, and it does its thing, launching air cannon. It suspends as normal, and then when it gets down to here, it waits until this coroutine is done. And in fact, if you look at a wait, it is a suspending function. So it zips these two different worlds together, it connects these two coroutines. This outer coroutine waits for this inner coroutine at this line. Okay, let's run this and see how it works now. And we're going to keep an eye on the text here. We're going to watch the text. Excellent. Okay, so here we use this deferred to kind of keep some structure to our concurrency, hence structured concurrency. This is a theme that follows when you hear people talk about coroutines. They use this term a lot. Now, how else does structured concurrency help us? Well, another idea, another concept is canceling. Not only do you want to keep track of your work, but sometimes you want to cancel your work in the background. So earlier I mentioned that we can imagine this is running on the main thread of an activity in our Android application. You could also imagine it being an activity or a view model or a fragment or a service. These are all lifecycle aware components. And what I mean by lifecycle aware is that these components could be killed at any time by the OS. So you have to be ready at any moment. You need to be ready to cancel your background work. Okay, how do you do that with coroutines? Well, the answer is the scope. This scope actually returns an object called a job. Okay, so this job allows us to cancel our work. So I'm going to print here. Now, what does it mean to cancel a coroutine? So if any of you are familiar with threads, if you've ever tried to interrupt a thread, it's similar with coroutines, same idea. When you try to cancel a coroutine, it only cancels a coroutine that is actually suspended, right? So for example, if we look at this code, right, this is a coroutine here running, right? This is a coroutine running inside of here, but it's only suspending at this point. It's not suspending here. This is printing. This is printing. It's not suspending here. It's only suspending here. So when you call cancel on a job, it tries to cancel all coroutines, not only in the parent scope, but in any child derived scopes as well. Okay, that's important. That's more that structured concurrency I was talking about. But again, it only does it, you can think of it as best effort. It only cancels if the coroutine is actually suspended. Now, what does that mean? How does that affect us? That it can happen. So what does it mean that it only cancels if it's suspended? Well, let's see. Let's run this and see what happens. So we've canceled this job down here, or so we think. Let's see what happens. Okay, canceling, get down. Okay, so we canceled it at some point. And the good thing is it didn't fire the air cannon, right? We don't see launching air cannon, right? Remember, this is what happens when you launch. So we don't see launching air cannon here, but we do see get down, right? We can see that, that's good. But let me show you something weird. The siren's still on, right? That is not good. This is something we did in the background, right? We turned on the siren, but it didn't turn off. How can we fix that? So this is what I was talking about. It's best effort. And when you cancel a coroutine, you need to be aware of things that could be lingering, right? So we need to fix this. Let me turn this off before it drives me nuts. Okay. Let's go back to here. Let's talk about a little more about this canceling. So when you cancel, in detail, what happens is if you have something that's suspended, the coroutine will throw an exception. It'll throw a cancellation exception, right? So if you're running here, it won't throw an exception. But if you're suspended, say here, this is actually a suspending function, by the way. You see that? Sleep is a suspending function. So when I run this coroutine in the background, right? I turn on the siren and then I sleep for 5 seconds. And during those 5 seconds, this coroutine is actually suspended. And in fact, it's this point where it threw the exception. And because it threw the exception, right, it bubbled up, it exited, and it never ran off, and it never printed, okay, you can get up now, right? That's why you see this. That's all it's there. And that's why the siren stayed on. It never reached this line of code. So we had to clean up properly. So what way we do that is we'll do try. catch, right? And what it throws is a cancellation exception, okay? Oops. Okay, let me drink of water here. Okay, so what we're gonna do here is learn how to type. Okay, okay, we're gonna say exception, right? But we're gonna do one more thing. We're gonna do some cleanup work. Remember, that's what finally is for. We're actually gonna turn off the error raid siren. Maybe we're gonna do that too. We'll put that in there. So now not only will it catch the exception, but it's gonna do some cleanup work. Let's run this and see how it works. Remember last time we did this, the red siren stayed on. Okay, exception. So we proved that this is in fact where we threw the exception. And look, the siren's off. So we fixed our problem. So that actually concludes, let me get rid of my air raid siren. That actually concludes the talk. Let me scroll up to the top here. I'm gonna get rid of this. And now I'm going to answer any questions you folks may have. Okay, just waiting for some questions here. Okay, hello. Okay, there you go. Okay, folks. So now we're going to do a Q&A period. You can just go to this website, slider.com, use this QR code, and you can ask questions that you may have. Oh, great. So we're getting some great feedback here. Thank you so much. That was some from Chrissy. This was definitely the most fun way to learn coroutines. Thank you. You're welcome. Um, okay. So the second question from Anonymous this was a brilliant talk, Nicholas. I want to know how your Kotlin code is talking to the IoT devices. Okay, yeah. So the Kotlin code is talking to the devices using retrofit. And so when you, again, what I said back in the beginning was retrofit does this cool thing. You tell it which endpoint to go to, and then it actually compiles and builds into it all the network calls necessary using retrofit. Okay, now I see another question here is, can you tell something about your scope that you were using? Yeah, so great question. So this scope that I'm using here, right? This is a little bit of magic. If you just look at it, if I just scroll up here, I'm showing you behind the curtain here. Up here, this is where I create my scope. Okay, coroutine scope. This is my constructor, and you see a scope is defined by both a dispatcher and a job. Now, often
Nick,
when should I try to share my screen or no? Okay, okay. Okay, great. So folks, I apologize. I've been informed, silly me, you can't see my screen. So, um, so yeah, so the scope is actually just created. It was instantiated above the demo code that I was typing. So it was explicitly created in that method that you above in the main method that was launching my do something method. So there's a little bit of hand waving there. But normally when you're doing most Android coding, your scope is provided for you. For example, if you're in a view model, it's provided by the Kotlin extensions, and you get the view model scope. Um, okay, so another anonymous question here is, what if we don't start any thread in suspend function? Does that execute everything in suspend function before the rest of the code? Great question. So first, if you don't change threads anywhere inside of your suspending functions, then you've really wasted your time using coroutines, right? And that's okay because you learn. So yes, if you don't suspend, it'll just go through and return like a normal function, and the function actually won't suspend. So the suspend keyword kind of means I might suspend at some point. But in fact, you might get a warning. I forget if you've written a suspend function, right? If you put the suspend keyword in front of a function declaration, and if you don't inside of there switch threads, or if you don't call another suspend function inside of it, I think you get a compiler warning. Um, okay, are there any more questions? Because I've read all the questions I see so far. Um, Okay, so we have a few more questions. Great. So for Parush, and I apologize if I'm not pronouncing your name correctly. Parush asks the question, can we cancel something which has been invoked by deferred.await? So yes, in fact, deferred.await is a suspending function. Okay, remember, await, it suspends. So you absolutely, if your coroutine is suspended at that point, remember my example, we had the outer coroutine, right? And it was waiting on that. It was suspended on that await. It was ducking.await. If I had canceled, and if it's sitting at that point, that await would have thrown an exception. Okay, anonymous, you're awesome. Oh, thank you. It's good in these times to praise each other, and I love praise, so please keep it coming. Love the way you explain coroutines. Will this talk be available to watch later? Absolutely. One of the benefits of the online conference is everything gets recorded. Okay, can we join output like an RxJava? Yes, you can join. You can do all that with coroutines. You can join jobs, that kind of thing. What about RxJava? Will it be replaced by coroutines? That was another question someone had. What about RxJava? Will it be replaced by coroutines? That's a great question. And the answer is no. I think if you're doing new work, you should use coroutines because they are much cleaner. But frankly, as I've gone over the years as I've used coroutines, I found that there are some operators in RxJava that are really hard to reproduce in coroutines. I've had to actually build some myself. So you're always going to need some coroutine maven in your organization to kind of build these operators that aren't available yet in coroutines, but that's actually getting better and better. So in general, I would say that if you have a ton of code that's using RxJava, you should not change it. You should keep RxJava if you have a bunch of legacy code. But if you have new code, you should use coroutines. Okay, next question by Anonymous. Just want to confirm if I have thread.wait or thread.sleep inside a coroutine function, will it nullify all the benefits of coroutines, meaning that thread cannot be used for that at that time. Okay, so we have a question here about how to use both threads and coroutines. Yeah, I wouldn't do that. Okay, so I think that's kind of an anti-pattern. It's kind of like in general, I think, and I'm this is a general statement, but in general, if you see the word thread in an Android application, you're probably getting yourself into trouble. You should avoid explicitly using threads, thread.wait and thread.sleep. If you use them, I haven't really thought of how. It's a good question. I'm not really sure what that would do, but I wouldn't do it. That may be kind of cheating. That might be an easy way out of the question, but I think it's probably a code smell, and you want to try to avoid that. So while we're waiting for the next question, I think we have another minute or so. I think that's about it for the questions. Thank you all very much. These were great questions. I appreciate your time. Oh, hold on. I'm sorry. We have some more questions. Well, let me finish my point. I had a great time presenting to all of you. We have a few more questions here. I think you missed this. Awesome presentation. Can you please explain when cancellation exception is already handled by Kotlin? Also the difference between cancel and close, please. Okay, so explain when cancellation exception is already handled by Kotlin. So, cancellation, they don't bubble up. They don't leave the coroutine world. If your cancellation exception bubbles up to that first launcher, the builder, it won't bubble outside of that. Your coroutine will just leave. So it doesn't crash the app. Okay. Example, difference between cancel and close. I'm not sure if I know the answer to that. You mean job.close? I'm not sure if I remember that one. I'm sorry. Um, does Coroutine have thread pull and buffered queue like executor service? So it has a thread pull. That's where those the dispatcher is, right? The launch, and you have in the parentheses that dispatcher. That is the thread pull. Buffered queue. So when you start talking about buffered queue and things like that, you're talking about queuing up work, and to do that, you use broadcasters. You use channels in coroutines, channels and flows, those kinds of things. So you want to look into those subjects. That's where you start to get into like queuing up work and using like mutexes and that kind of thing. Next question from Parush. Second question from Parush. Thank you for the questions. They're awesome. All these questions are wonderful. Another question is using try catch block is the best idea to handle cancellation of coroutines. I was expecting yield or is active for that. What are your thoughts on that? So is active is a way. So is active is if. So great question. Is active, Parush mentions is active. So what that is if you're inside of a coroutine, and let's just say you're doing a computation. Okay, remember I said your coroutine will only be canceled if you're suspended. Well, what if you've got some kind of loop that you're working on where you're getting some data and then you're crunching it with a process and then you're getting more data? What if you're doing that process and you've already been canceled? Well, that's where you use is active. You say, hey, have I been canceled? Because if I've been canceled, I really should leave, right? We see this with threading, but yes, so that's what is active is for. Okay, honestly, I think let me answer this last question here. Follow up for thread.wait question. Currently, shared preferences has wait inside the get function. So if I'm calling from inside, I cannot take the benefits of suspending. Good question. Yeah, good question. I'm not sure I can answer that. All I know is that shared preferences has a new paradigm, right? There's a whole new paradigm for shared preferences. If you haven't seen that, you can check that out. That might help you understand the latest contemporary way of using shared preferences and coroutines. So I think that's about it for questions. I think we're wrapping up here. I don't want to be a conference hog. So once again, I want to look to all of you and say thank you so much for joining my talk. I hope you've learned something. And please check back later. All these talks are recorded. And eventually you will see this talk recorded. And thank you so much. Have a great day and enjoy the rest of the conference. Bye-bye.